name is Denise, and today I wanted to talk to you about two features of a sine graph. So as we're graphing the angle sine of theta, starting at 0 degrees and going up to 90 degrees, onto 180 degrees, and so on, what is that graph going to look like? And it turns out that it will show some patterns that will keep repeating, and we can take a look at a couple of key features of that graph that will help us understand the shape that we see and how it's going to behave in different situations. So the first thing that I wanted to talk about is that a graph of a sine wave, just like the graph of a cosine wave or tangent, is periodic, which means that it repeats over intervals. So the very basic graph of a sine wave I'm going to show you looks like this. So we've got, it starts at 0 degrees here, and it's going to go up to 1 as we move from 0 to 90 degrees. And then as we keep going beyond 90 degrees, it's going to go down back towards 0 at 180. But it's not going to stop at 0. It's going to keep going into the negative until it hits -1 right here at 270 degrees. At that point, it'll go back up towards 0 at 360 degrees because the sine of a 360 degree angle is here. So you can see it makes this pattern. Up a hill, go back down, cross over, down a hill, go back up to 0. That interval right there, that shape, keeps repeating in every direction. So as we keep going into higher angle values, it's going to keep going on this way. And if we did negative angle values and took the sine of those angle values, we'd get the same pattern over here. So I did a dotted line to see how it repeats as it goes beyond. But this chunk of space here, where we see one copy of the pattern of a sine wave, that's called the period. So the period of a basic y equals sine theta graph is 360 degrees. It takes 360 degrees to show one loop of that pattern, and then each 360 degrees beyond that, it's going to keep repeating. We can also talk about how high up and how low down does it go. That's called the amplitude. So for a basic y equals sine theta graph like this one, we see it goes up to a maximum of 1 and then down to a negative, or a minimum of -1. So it goes a total of 2, right? But basically the highest up you're going to be able to go is 1, the lowest down you're going to be able to go is 1. So the amplitude of this graph is 1. Basically, how high up are you going to be able to go, or how low down are you going to be able to go, or half of the distance between the maximum and the minimum. Now, depending on the way the equation is written, we can have different amplitudes than 1. I'm going to show you how that will look. So in this graph, I drew 3 graphs on top of each other. Hopefully you can see them all. The middle one is the same graph that I drew last time. Regular y equals sine of theta goes up to +1, crosses at 0 at 180, down to 1, back to 0. That's the usual one that we were talking about before. But on top of it, I've also done an orange graph here that goes up higher. And so for that graph, what I did was y equals 2 sine theta, and how that changes it is the amplitude now is going to go up twice as high to 2. It's still going to cross over here at 0, 180, always does. Then it's going to go down to -2 before going back up to the usual place of 0 at 360 degrees. But now we've got this coefficient in front of the sine. They use the letter A right here for amplitude. And whatever you put in that space where that A is going to affect the amplitude of the graph. If you put in a coefficient like 2 or 4 or 6, that's going to stretch the graph up. So if you put in y equals 6 sine theta, it's going to be really big and spiky and then go down really low and spiky. You can also put a fraction in, like I did in this one, y equals 1/2 sine. That's the little tiny hills here. Instead of going all the way up to 1, it stopped at 1/2 and then hit 0. And then instead of going all the way down to 1, -1, it stopped at -1/2. So if you put a fractional coefficient in that spot for the A, it's just going to make your sine graph more mellow in between a lower max and a lower min. If you put, again, the big coefficient there, it's going to stretch it up and make it big and spiky. But so that's how you change the amplitude of a sine graph. And in this example, you can see it's still going over the same period of 0 to 360 degrees and repeating on each direction. So those are the two initial features of a sine graph, amplitude and period.